Welcome to the first chapter of the third course in Python programming. The name of this chapter would be Files and Stuff. So far we have only gone through a lot of, let's say, programs which we deal with objects inside the interpreter. But in this chapter, let's go ahead and take a look. Let's take a step further to interact with the outside world, with the operating systems and their files. So we can probably open files with the open function, which has some syntax like this. I'll write a pseudocode. It's like this: open parentheses name bracket comma mode bracket comma buffering. I'll be explaining this to you in detail, so you don't need to worry about what these things are exactly. Perfect. So just ignore this. I'm just letting you know how this code is being written. This is just a pseudocode. And the open function, it takes a file name as its only mandatory argument and returns a file object. The mode and buffering arguments are both equally important, and they will be, but they are optional and they're not actually necessary that you should go ahead and write that. In the earlier versions of Python, open was a separate function, but after Python 2.2 onwards, open is the same as file, the file type. So when you call it as a function, you're actually using the file constructor to create a file object. So assuming, let's go ahead and create a random file over here. I'll be creating the random file over here, and I'll name it as, let's say, text document, and I will write file period txt. And let's say I want to open, I'll just write something in this. Let's say hello world. It doesn't matter what you write, I'm just writing anything that we can write in a txt file. And I'll just write in the interpreter over here, such as, let's say, assuming that you also have the same operating system that I have, that's Windows 8. I'll just go ahead and write, let's say, first I want to go ahead and access the same path, so I'll just write f, let's say, equals to open, and I'll write c colon, and I'll be using this. No, sorry, I have not yet stored in C. I have stored it in E. Just let me check. Okay, it's E, and I'll just paste it over here. But the difference is that I would have to use the forward slashes rather than the backslashes, since I'm using this in the interpreter. Okay, perfect. Let me check. Let's go ahead and check whether this works, and I don't want an E over here. 2 and 5, perfect. And I will also write down the name of the file. The file name is file period txt. Let's check if it is open. So no such directory, e colon forward slash. Okay, so just let me check. Let's go ahead and save this in the C file over here. And okay, perfect. And let's check if I would be able to open this, because I may not have. Okay, this is, and I'll write, let's say, c colon txt. It should be file period txt. And okay, perfect. Okay, it's opened, I believe. Now there is no such file or directory. I will use the apostrophe r, and let's check if that works. And I'll write open parentheses r apostrophe, and I'll write c colon backslash, and the file name would be file period txt, and parentheses. Let's check if this works. Okay, so thing is that it is not detecting the file over here right now, maybe because I don't have sufficient permissions for that. But this is how we can go ahead and create a file. As of now, it's not able to search the file, maybe because I did not use the import file to go ahead and import the path. That may be the reason. But over here, this is how we can go ahead and use that. Since the file, it's not able to find the file, it's showing me an exception that no such kind of file exists over here. So if we use the open with only a file name as a parameter, we will get a file object that we can read from. If you also want to write to a file, we should have to state that explicitly supplying a mode, and the mode argument to the open function can have several values. Let me just open my text. Okay, so if you go ahead and write the argument as R, that means it has a read mode. If you write it as W, it means that it has a write mode. A means it has append mode. B means it has a binary mode, and plus means it has write as well as a read mode, and it can also be added to other modes. So explicitly specifying read mode has the same effect as not supplying a mode at all. The write mode enables us to write to a file, and the plus mode can be added to any of the other modes to indicate that both reading and writing is allowed. So for example, let's say R plus can be used when opening a text file for reading and writing. The B mode changes the way the file is handled. Generally, Python assumes that we are dealing with the text files. Typically, this is not a problem, but if we are processing some other kind of a file, such as sound clip or image, or then we should add a B to our module. For example, RB to read a binary file. That's how we should work. And you might be thinking that why we should use a binary mode. If we use a binary mode when we read a file, things won't be much different. We are still able to read a number of bytes and perform other operations associated with the text files. The main point is that when we use the binary mode, Python gives us exactly the contents found in the file, and in the text mode, it won't necessarily do that. If you find it shocking that Python manipulates our text files, don't worry. The only trick it employs is to standardize your line endings. Generally in Python, we end our files with a new line character such as \n, as in the normal Unix system. This is not standard in Windows, however, but in Windows, a line ending with a marked forward \n or \r. So to hide this from our program, Python does some automatic conversion here. When we read a text file from a file in a text mode in Windows, it converts the \r\n to just \n. Similarly, when we write a text into a file, text to a file in text mode in Windows, it converts the \n to again to \r\n. And the Macintosh version does the same thing, but it converts the \n and \r. So the problem occurs when we work with the binary file, such as let's say a sound clip. It may contain bytes that can be interpreted as line ending characters mentioned in the previous paragraph, and if we are using a text mode, Python performs its automatic conversion. However, that will probably destroy our binary data, so to avoid that, we simply use the binary mode and no conversions are made. Just note that this distinction is not important on platforms where the new line character is the standard line terminator, because no conversion is performed there anyway. And files can be opened in universal new line support mode as well, using the mode character U together with, for example, R. In this mode, all line ending characters, strings, are converted to new line characters regardless of which convention is followed on the current platform. And buffering, the open function takes a third parameter which controls the buffering of the file. If parameter is 0, then input output is buffered. If it is 1, input output is again buffered. Sorry, if parameter is 0, input output is unbuffered, but if it is 1, it is buffered. And instead of a disk space to make things go faster and only update when you use flush or close, then larger number files indicate the buffer size, while 1 sets the buffer size to the default. The basic file methods that I would be teaching you. Now you know how to open files. The next step is to do something useful with them. In this section that I will be teaching you in the next tutorial, we will learn some basic methods that the file objects, some other files like file-like objects, that how important they are and how we can go ahead and use them for creating our different programs. And before I proceed, there are three standard streams. A standard source of data is called as sys period stdin, that means system standard input. Another one is system standard output, and another one is system standard error, that means error. And I probably gave you a hint in one of the previous courses what this is all about, but in this course I'll be teaching that to you in detail.